Hi students, it's Mrs. Gifford. Today we're going to do lesson 2.8, which is proving angle relationships. And after this lesson, you'll be able to write proofs involving supplementary, complementary, congruent, and right angles. Before we continue, I just want to make sure that you grab your little theorem sheet, the little handout where you can fill in the different theorems and postulates, because this one has quite a few for you to put on that sheet. So let's get into it. All right, so the first one is postulate 2.11, and it says the angle addition postulate. And basically, angle D is the interior of angle ABC. So it's telling us that angle ABD, right here, plus angle DBC, this inside one, equals the exterior angle. So it's basically telling you two angles make up a third angle. So let's take a look at example 1, where it tells us the measure of angle 1 is 23 degrees, and the measure of angle ABC is 131 degrees, and we have to find the measure of angle 3. And we're going to justify each step. So from here, what are we given? Just like we did before, we are given angle 1 is 23, angle ABC is 131, and we need to prove, or we need to find, the measure of angle 3. All right, so from here, here's our proof, just like we did before. We're going to list our proof and our reasons. So the first thing that I'm going to do is write down angle 1 plus angle 2 plus angle 3 equals 131 degrees. And this is the angle addition postulate. Okay. Then we have 23 plus 90 plus angle 3 equals 131. And this is from our given information. And I forgot to put up here in the given information, but angle 2, the measure of angle 2 is 90 degrees, and we know that because it's got that little right angle designation there, so let's put that in. So from here, what can we do? We're going to use all of our algebra, actually, and solve this algebraically. So the first thing we want to do is add our 23 and our 90. So we get 113 plus angle 3 equals 131, and this is just substitution. And from here, we want to subtract 113 from both sides. And so we get angle 3 equals, oops, I didn't mean to write subtract 113. Oh yeah, I did mean to subtract that, sorry. Okay, so angle 3 equals 18 degrees. Okay, so from here, what did we do with that subtracting of 113? This is the substitution property of equality. Okay, by subtracting that equals 13. So we figured out the angle 3 is equal to 18 degrees. Okay, that's using the angle addition postulate. So moving on, we have two theorems here, the supplement theorem and the complement theorem. Basically, the supplement theorem just basically says when two angles form to make a straight line, it equals 180 degrees. And the complement theorem says when two angles make this right angle, they add up to 90 degrees. So add those onto your sheet. Okay, so now let's take a look at example 2. It tells us that angle 6 and 7 form a linear pair. If angle 6 is 3x plus 32, and angle 7 is 5x plus 12, we need to find the measure of angle of x, angle 6, and angle 7. So our given information, angle 6 plus angle 7 makes a linear. So in your heads you should be thinking already that's going to be supplementary. Okay, and we know angle 6 is 3x plus 32. And we also know that 7 is 5x plus 12. we need to prove or find the value of x, the measure of angle 6, and the measure of angle 7. Okay, so from here I'm going to start this with writing angle 6 plus angle 7 equals 180 degrees. This is the supplement theorem. I'm going to abbreviate theorem as TH with a superscript M. Okay, and then I'm going to take what I have for angles 6 and 7. So we know that 6 is 3x plus 32. And we know angle 7 is 5x plus 12. What's that? That's just substitution. From here, then we need to recognize that we have some like terms, so we're going to simplify it. 3x plus 5x gives us 8x. And then we have a positive 32 and a positive 12. That gives us 44. That's also just substitution. From here, just like we did with the last example, we're going to solve for x. So we're going to subtract 44. Whoops, not 18. That should be 180. All right, so we're going to subtract 44. And so we get 8x equals 136. What did we do here? That's the substitution or subtraction property of equality. And then our last step here is to divide both sides by 8. Oops, I'm going to run out of space here. So I get x equals 17. And from here, that's the division property of equality. All right, moving on. So the next one, we have theorems 2.5, 6, and 7, and also the symmetric property of congruence. So I'd hit pause, take a few minutes, and put these on your sheet. All right, so let's take a look at example 3. In this figure, we know ABD and DBC are right angles. We need to prove that ABD is congruent to EBC. So that's our job, ABD congruent to EBC. So what are we given? In here, we know that angle ABE and angle DBC are right angles. And we need to prove that ABD is congruent to angle EBC. So let's follow our steps here. First thing that I'm going to do for our statement is write angle ABE equals 90 degrees and angle DBC equals 90 degrees. That information is the definition of right angles. So then I know that ABD and angle DBE are complementary. Okay, and angle DBE and angle EBC are also complementary. And how do I know that? That's from the complementary theorem. So because of that, and looking what we have here, notice DBE is used in both statements. So we can say angle ABD is congruent to angle EBC. And why is that? That's because of the congruent complements theorem. Okay. All right, hit pause again. Take a few minutes to fill in these particular theorems about vertical angles and right angles. Okay, now I'm back for example 4. Okay, so 3 and 4 are vertical angles. 3 equals 6x plus 2. 4 is 8x minus 14. We need to find angles 3 and 4. So, given angle 3 and angle 4 are vertical. Angle 3 is 6x plus 2. And angle 4 is 8x minus 14. And we're going to prove, or we're going to find, the measure of angle 3 and the measure of angle 4. So first things first, we know that angle 3 is equal to angle 4. And why is that? It's the vertical angles theorem. Then I'm going to say, okay, well, I know that angle 3 is 6x plus 2. And I know angle 4 is 8x minus 14. And I can do that because of substitution. Okay, and from here I'm going to subtract 6x. Because I'm going to get, eventually I'm solving for x is what we need to do. So I have 2 is equal to 2x minus 14. And that's the substitution property. Property. Oh, give me the marker. All right, substitution property of equality. So I have my 2 equals 2x minus 14. So from here, again, I'm shooting to get this x by itself. So I'm going to add 14 to both sides. 2 plus 14 gives us 16. Okay, and that's the addition property of equality. Okay, and then I need to divide both sides by 2. And so I get 8 is equal to x, so that's one of our first values, and that's the division property of equality. Okay, and now that we know that x is equal to 8, I'm going to use the fact that angle 3 is 6x plus 2. So I'm going to substitute 8 in for the x, and now I'm going to solve. So this is substitution. 6 times 8 is 48. 48 plus 2 is 50. So we know the measure of angle 3 is 50. That's also substitution. Then we're going to do the same thing, and now we're going to talk about angle 4. Well, we know that angle 4 is congruent to angle 3. Okay, again, that's because the vertical angle theorem. So then from here, then I can just say, well, then I know that angle 4 is also equal to 50, and this is just substitution. Okay. All right. So the last thing, and I didn't put it in a slide, but the last thing, there are some theorems on page 153. Page 153 for some other theorems. All right, I know it's a really long lesson, but hopefully you have a pretty good idea of how to use these different theorems and postulates to solve or prove different angle measures.